Good morning. My name is Yong-Jun. I will present my final year project, which is entitled AI-based flood prediction system. First of all, let's look at the background of this project. In general, flooding events are categorized into monsoon floods and flash floods. This project focuses more on flash floods. For flash flood events, it normally occurs in the vicinity of major cities such as Kuala Lumpur and Georgetown. To tackle this issue, the system is developed based on the guideline provided by the Department of Irrigation and Drainage. This guideline categorizes the water level into 4 stages, which are normal, alert, warning, and danger. There are 3 problem statements in this project. Firstly, it is the time factor of the flood detection system. Time is a crucial factor, especially in detecting the rapid changes of water level for flash floods. If the time taken to complete the process is too lengthy, the trustability of the result is affected. Secondly, it is the availability of data. The data is significant to identify the status of water level and to predict future water levels. However, it is impossible to install the workstation in every section of the river due to the cost factor. Thirdly, it is the algorithm to forecast the future values. There are too many forecasting algorithms in the market that can forecast future values. However, not all of the algorithms are applicable in flood prediction scenario, as flood prediction scenario depends on the geographical layout of the regions. Now, let's look at the objective of this project. The first objective is to design a flash flood monitoring system with yearly prediction mechanism. The second objective is to analyze the performance of the ARIMA and Prophet algorithms in predicting the future water levels. For the project overview, the system takes 3 data, which are water level, temperature, and humidity, as the input of the system. However, the water level has the highest priority as it is the essential element in flash flood detection and prediction system. The flood detection system categorizes the water level into 4 stages, which are normal, alert, warning, and danger, while the flood prediction system forecasts the values of water level for a series of timestamps. In this project, ARIMA and Prophet are analyzed to choose the best fit algorithm for flash flood predictions. Lastly, the output of the system is displayed on a web application in the forms of charts and tables. Now, it is the methodology of this project. The project starts with the background research and study on the topics related to AI-based flood prediction system. After that, the planning of the system design is carried out before the system implementation. This project contains 3 subsystems, which are flood detection system, data visualization system, and flood prediction system. Also, a landing page that links all these subsystems is developed. Troubleshooting of this application are carried out to ensure that the system is well functioning. Last but not least, the result analysis is conducted to determine the best fit algorithm for the flood prediction system. Let's look at the demonstration of the project. As mentioned, this project is divided into 3 subsystems, which are flood detection system, data visualization system, and flood prediction system. To link all these subsystems together, a landing page was developed using HTML and CSS. The web page that we are viewing at is the landing page of this system. By clicking on this button or this button, the system will direct the user to the corresponding subsystem. For the flood detection system, it reads and preprocesses the real-time data acquired from the workstation via ThinkSpeak API. A pre-trained AI model is then applied to categorize the data into 4 stages, which are normal, alert, warning, and danger. Also, this system integrates PostgreSQL database, meaning that the result generated by this system is stored in the database. This system presents the result in tables, which are the table that record the result by months and by days. However, the system only updates this table if the status of the water level detected is different. Besides, the data visualization system reads the result kept in the database and retrieves the real-time data from the workstation. The result and data are presented in the forms of charts and tables. The sidebar at the left allows the user to select the desired data to be displayed on this system. So, this is actually the data retrieved from the database that records the result by months. Also, now let's look at the visualization for the data that retrieved from the API. So as you can see, the data are presented in graph. Last but not least, the flood prediction system forecasts the next 6-hour water level values according to the data retrieved from the workstation as well. This system applies Prophet algorithm and it has better performance than the ARIMA algorithm after the analysis was conducted. Moreover, the system applies the same classification model that is used in the flood detection system to detect the status of the predicted water levels. The predicted water levels and their respective status are recorded in tables, and the graph of the input and predicted time series data is plotted in the graph as well. Referring to this table, this is the analysis conducted to identify which algorithm is the best fit algorithm in this scenario. Mean absolute percentage error (MAPE) and root mean square error (RMSE) are the performance metrics used to evaluate the performance of the algorithms. According to the table, Prophet records lower values of MAP and RMSE, meaning that it has better performance. These are the plots of the original series and the predicted series generated by both ARIMA and Prophet algorithms. In conclusion, a flash flood monitoring system with an early prediction mechanism is successfully developed. Also, after the analysis was conducted, Prophet is proven to be better than ARIMA model in flash flood prediction scenario. The project is in high demand, especially for the areas that are troubled with flash floods. However, more research and study are needed to improve the system. Shortly, this project gives a huge impact to the society as it can prevent loss of lives by alerting the relevant authorities based on its forecast. That's all from me. Thank you.